discharge line, the mud goes through the standpipe and rotary hose to the drill string equipment. The shale shaker mechanically takes out the large cuttings from the mud. It does not, however, remove very fine cuttings and other small solid particles. These solids can be fine sand particles and other very fine materials, often called silt. Good drilling practice requires removing these undesirable solids. If not removed, the solids can increase the weight of the mud more than required, reduce the bit's penetration rate, and significantly increase the rate of wear on circulating equipment. The rig uses mechanical solids removing equipment, such as hydrocyclones and centrifuges, to remove the fine solids. Sometimes, the hole penetrates a formation that has small amounts of gas. This gas gets into the mud, becomes entrained in it, and must be removed before the pump recirculates the mud back down hole. A degasser removes entrained gas from the mud. The shale shaker has rapidly vibrating screens. The mud and cuttings from the return line fall onto it. The vibrating screens catch the larger cuttings. These cuttings fall into the reserve pit, the sea, or other container for disposal. The liquid mud goes into the sand trap, which is a special mud tank. Shale shakers look simple. In fact, though, manufacturers carefully design them to make the screens vibrate in a very controlled way. Sometimes, the crew sends mud through a vacuum degasser. The degasser removes gas from the mud. If the gas were not removed, it could make the mud too light, not dense enough. As a result, the well could kick. Formation fluids can enter the well bore and have to be controlled to prevent a blowout. Another problem: if the driller recirculates gas-cut mud, the gas could cause the mud pumps to gas lock. Gas-locked pumps pump gas and mud instead of just mud, which is highly inefficient. So, to remove gas, crew members use a degasser. In a vacuum degasser, mud with gas in it enters at the top and spills out over several baffle plates, a spreader. Spreading out the mud presents a large surface area for the gas to break out. Also, the vacuum pump creates a vacuum, pressure lower than the surrounding atmosphere, inside the degasser. This vacuum makes it very easy for the gas to escape from the spread-out mud. The removed gas leaves through a vent, which sends the gas a safe distance away from the rig. The gas-free mud falls to the bottom and goes back into the mud tanks downstream from the degasser. A hydrocyclone system consists of several cones. Mud enters through a side opening at the large end of each cone. It swirls around inside the cone. This centrifugal force, or cyclone motion, throws the larger particles to the side of the cone. There, the particles move to the bottom of the cone and drop out. Clean mud goes out the outlet at the top. A desander has large cones. It removes particles as small as about 40 microns. A micron is 1/1,000,000th of a meter, which is very small. A desilter has smaller cones than a desander. Desilters remove particles down to about 20 microns. A mud cleaner has still smaller cones. It removes particles down to about 7 microns. Since barite, that desirable solid which gives weight to the mud, is also about 7 microns, screens are included on mud cleaners to retrieve the barite so it can be returned to the system. Inside the cone, mud enters from the side and spirals down. This movement flings the solids to the side. The spiraling action creates a vortex in the center, somewhat like a tornado. It is an area of lower pressure, so the vortex sucks the liquid mud up through the center and out through the top of the cone. Meanwhile, the solids slide down the side and out the bottom of the cone. The smaller the cone, the smaller is the particle it can remove, but more cones are needed to handle a given volume of mud. A centrifuge spins mud at high speed. This creates centrifugal force. Centrifugal force throws the particles to the side of the centrifuge, where they are removed. A centrifuge removes particles as small as 2 to 5 microns, which includes barite. Sometimes, crew members run a centrifuge at a specific speed to remove barite, so the rig can use it again on the next hole. Occasionally, the rig owner runs 2 centrifuges. The first removes the barite, and the second the finer particles. Crew members then re-add the barite to the mud system. Crew members mount agitators on